Hi class, I wanted to talk a little bit today about solving quadratic equations. Alright, so quadratic equations degree 2, alright, equations with an exponent of 2. There's a few ways that we've probably talked already about solving these. You can factor these, that's always where I like to start first. You also have the quadratic formula, which works for these. You can also solve by graphing, but right now I'd like to talk a little bit about a technique that's often useful called completing the square. Alright, so I'm about to do an example where completing the square is quite challenging. However, I wouldn't necessarily use that method in this case, but I wanted to go over this technique so that if we can do a difficult one, it'll be easier for more simpler problems where it's a good technique to use. Okay, so let's take a look at this problem right here. This is from the prerequisite section P5, and it is problem number 18 from page number 50. Alright, so let's give this a go. Alright, first off, I'm noticing lots of different terms, but all of the terms are either quadratic, linear, or constant. Okay, so let's combine like terms. So I'm going to do some simplifying. Alright, so we have 3x squared minus 6x minus 7. Going to leave the left-hand side alone, but the right side's a little bit messy, so let's try to clean up a little bit. I got to be careful about this distributing. Not forgetting to distribute the negative sign along with the x. Alright, now let's combine like terms. Alright, so when I have a quadratic like this, where I have quadratic terms and linear terms, I know I think I'm going to have to factor. In this case, it's going to turn out to be non-factorable, but we still want to combine all the like terms and set it equal to 0. We always want to do that. So when we have a quadratic term and a linear term, bring all these terms over and set it equal to 0. Alright, so first off, an x squared and a negative x squared, gone. Alright, so I'm just going to have this term right here for the quadratics. Now let's look at the linear. So on this side I have a 3x and a negative x, so I have two x's on the right hand side. So I got to subtract those over here, so I'm going to have negative 8x. Now let's look at the linears. Negative 7 here and a positive 3 here, so I'm going to bring that over, so I have to subtract that. Alright, so that's always our first step. When we have a quadratic equation that also has linear terms, we want to bring everything over and set it equal to 0. Alright, so already this looks a lot easier. At this point, you would usually want to see if you can factor it. In this case, we'll come up a little bit empty. We will not be able to factor this one. So normally I would recommend going with the quadratic formula, but like I said, I wanted to go over completing the square. Alright, and this one's going to turn out to be hard. There's going to be fractions. So here we go. Alright, so completing the square is usually easy when this lead coefficient is 1. In this case, it's not 1, so that makes life a little bit more difficult, but we can still do it. First step, we want to divide everything by 3, alright, so that this does become a 1. So we have x squared minus 8/3 x minus 10/3 equals 0. Alright, so now we're a little bit better for completing the square. I know it doesn't look prettier. Next, different teachers have different techniques. What I like to do is bring the constant term over. Alright, so when you complete the square, you really only look at these terms here. So I'm going to bring the constant term over. So I'm going to rewrite this like this: x squared minus 8/3 x, and then I'm going to leave a big space so that I can complete the square, and then that equals 10/3. So I brought the constant term over. Alright, in this space right here, we're going to complete the square. Alright, when you complete the square, you need to look at this number right here. Alright, so that's the coefficient of the linear term. Alright, usually we call that the b value. You know, an ax squared plus bx plus c equals 0. This number right here is what we need to look at in completing the square. Okay, so we take this number right here, we cut it in half, so 8/3, and we want to divide it by 2, and that gives us 4/3. Alright, after we divide it by 2, we want to square it. And when we square it, that gives us 16/9. Okay, so that's our big number. That's what we're going to add in this space right here. Alright, 16/9. Alright, that guarantees that we have a perfect square here. Alright, now one thing that we have to be careful about, a big place where there are errors in completing the square, we just changed our equation, right? We added a value to the left-hand side, but not to the right-hand side. So we need to even it up. We need to add it to both sides. Alright, so now let's do some simplifying. We're going to factor this so that we can write it as a perfect square, and it's going to look like this: x minus, since this is minus, and then the square root of that, which is 4/3. Notice that's this, right? That's not a coincidence. That will always happen. And now we got to add these two fractions right here. Remember, when you add fractions, you need a common denominator. So our common denominator is going to be 9. So 10/3 we need to rewrite as 30/9. All right, 30/9 plus 16/9 is 46/9. ninths. Alright, so now we want to solve for x, so we want to isolate x, so we want to get rid of this 2, so we're going to take a square root of both sides, so x minus 4/3 is going to equal the square root of 46 ninths. Another place to be careful, when you take a square root of both sides of an equation, remember we need a plus or minus, right? Because think about x squared equals 9. If we take a square root of both sides, we get x equals 3. But doesn't negative 3 squared still equal positive 9? You betcha. Alright, so when you take a square root of both sides, you need to put in a plus or minus sign. Alright, so now let's add 4/3 to both sides to continue getting x by itself. So it's going to be 4/3 plus or minus the square root of 46 does not simplify anymore, but the square root of 9 sure does. That's 3. Alright, so there is our final answer. I know it doesn't look pretty, but that is our final answer. Earlier I mentioned that there were other ways to do this. Quadratic formula, graphing, factoring sometimes, not in this case. So give me 1 second. I'm going to show you how you can do this one also by graphing. Okay, so look at this equation that we have right here. 3x squared minus 8x minus 10. Alright, I loaded that in my calculator. Okay, so if we go to my y equals screen, we can see 3x squared minus 8x minus 10. That's one side of the equation, and the other side of the equation was 0. So I graphed both of those. And notice we get a parabola, like a quadratic graph should give us. And then the line y equals 0 we can't see, that's right there. Okay, so I want to figure out where these two expressions are equal, so that'll be where they intersect. Okay, so I'm going to go second trace to take me to my calc menu. Then we want option 5, intersect. When it says first curve, you hit enter. When it says second curve, you hit enter. When it says guess, you want to move close to the intersection point. I'm almost right on it, so I hit enter. All right, 3.594, remember that. Now let's find the other intersections. I'm going to do the same thing. Second trace, that'll take me to the calc menu. I want option 5 to find the intersection. First curve, enter. Second curve, enter. Now I want to move over to the other intersection point. So I just arrow over. When I get close, I hit enter, and I get negative 0.927. Alright, so remember those values that we got. Now I'm going to go to my home screen. I knew what answers we were going to get, so I plugged them in. So this is what we got from completing the square. Remember, 4/3 plus square root of 46 over 3, and 4/3 minus the square root of 46 over 3. And notice these decimals that we got by plugging in our completing the square work are the exact same as our graphing values. Okay, sure, the graphing was easier, but one plus here is when we completed the square, we got exact values. However, when we graphed it, we only got decimal values, which are not exact. All right, thanks, guys. Have a good one. If you have any questions, we can discuss in class.